Let's consider the graph of a tangent function. We have y is equal to 2 times the tangent of x over 2. This is of our general form, y equals a times the tangent of the quantity bx minus c. Now notice c is 0 in this case because we have no addition or subtraction inside. We can recognize that a is equal to 2 and that b is actually equal to 1/2. Now that we have a and b, let's go ahead and find our vertical asymptotes. The formula for our vertical asymptotes is bx minus c equal to pi halves. Now since c is equal to 0 and b is equal to 1/2, we can simply write this as 1/2 x being equal to pi halves. And I'm going to sneak in a plus or minus here on you. To find those vertical asymptotes, we're going to solve both sides for x entirely. Multiplying both sides, we obtain the equation x equals a negative pi for one vertical asymptote and x equaling a positive pi for the other vertical asymptote. So let's go ahead and draw those in here real quick. We want to draw those in. Know that our function 2 times the tangent of x over 2 is not defined at negative pi and a positive pi. We want to use this in our graph. Now you can see I have sort of a light outline here of y equals the tangent of x. What's going to happen is we're going to stretch this horizontally by a factor of 2 and also stretch this vertically by a factor of 2. And the horizontal stretch, it manifests itself in these vertical asymptotes. So just like before, we have our origin. We're going to have the point pi halves comma 2 and negative pi halves negative 2, and then we know how our tangent graph reacts around our vertical asymptotes. So let me draw this in for you here. There's the right hand side of our graph, and here is the left hand side. And again, as we get closer and closer to pi, our graph will asymptotically approach the equation x equals pi, and similarly on the left it's going to approach the vertical line x equals a negative pi without touching. And from this we have our graph of 2 times the tangent of x over 2.